So next slide, and then we're ready to get started. I'm hopeful that Igor Martin is here from Hydromea. Igor, are you with us?
I am, Michael. Hi, good morning.
Excellent. Then let's give the floor to Hydromea, which is a very innovative company from Switzerland. And we look forward to hearing your presentation. So again, 10 minutes approximately presentation, 10 minutes Q&A via chat, and then we'll hand it off to the next person.
All right, thank you, Michael. Yes, we are from Switzerland, so hello from Switzerland. It's a sunny day today here, and we are glad to be connected to the network and present our cool technology and how we are planning to upend the game in the underwater or subsea world. So we are really focusing on pioneering autonomous underwater inspections with our technology. We won a TechX acceleration program last year, got £100,000 in support, no strings attached. We were named top 10 ocean influencer by Echo magazine last year, and we were also featured in top 100 disruptors by Marine Technology for 3 consecutive years. And so let me tell you more about why and what we do. And I hope that the slides change. Yes, I think they do change. Fantastic. So the problem that we are focusing on addressing is that mandatory inspections and monitoring of submerged assets today is highly inefficient, whatever industry it is. And some of the examples are offshore wind, hydro turbines, aquaculture, and FPSOs, offshore platforms. It's pretty high cost, so it takes a lot of resources, and it costs a lot of money to inspect, for instance, a ballast water tank on floating platform. And the cost can go up to $200,000. Sometimes it also leads to health risks when people go into confined spaces for inspection. In certain industries, it's not possible today to get to an asset if not stopping the asset and maybe even taking it out of commission for the brief time, so which leads to asset downtime. And then if the inspections are not done properly or in time, as we know, that may lead to an accident, and that costs a lot of money and brand image. So there are a number of tools today to do those inspections. Some tools work better than others. Primarily for inspection of submerged assets today, human teams are used, which is, as I said, expensive and leads to safety risks. Aerial drones are starting to be used to survey the confined spaces, but they have very short endurance and pretty much very poor payload, for instance, to take measurements of corrosion in the tanks. ROVs, remotely operated vehicles, have started to be used, and they are doing a relatively good job, but for certain applications, tether management becomes an issue. So what Hydromea is focusing is we would like to bring to the market the world's first portable autonomous underwater drone. The drone that is small enough that can do ad hoc asset checks in various situations, would eliminate safety risks, increase asset uptime, and as a result as well reduce costs by at least a factor of 5. The market for autonomous vehicles in 2025 is going to be 1.5 billion, and that's the market where we are going to play in. However, this is the vehicle sales market. What we are focusing on as well is the service market. In a number of those industries, the clients really don't care how you get the data to them. They don't need to know what drone or ROV or what have you has been used. What they need is data that talks to their IT systems. And so our focus will be from developing the hardware to eventually getting into the data mold. And initially we are trying to show how technology works with Total, Chevron, GE, with whom we already have signed LOIs. So as I said, the business model, that's for people who are interested from the investor standpoint of view. But we are building right now a platform to enable this data capture. And the market access would be secured by partnering with service providers. But down the line, once the platform is being developed, we really are not a manufacturing company. We're a technology company, and the value that we deliver in the brains of the vehicles and the data that those vehicles collect. So the company has beginnings in the academia back in 2004 with two German engineers starting their journey in Australia, building a very small portable AUV. Then one went to Switzerland to join an aerial drone project in swarm communication, and another one went to MIT, got a PhD in underwater navigation together with Woods Hole, and then came to join Felix, the first one in Switzerland. In end of 2014, they put the company together and really focused on developing key enabling components because putting together a small vehicle was, at that time, was pretty difficult because there isn't really much available off the shelf. And so I'll talk about components a little later in more detail. In 2018, I joined as a late co-founder, and I'm coming from DuPont with 15 years of business development and running global business prior to leaving the company. So right now, we are focusing on augmenting strategic value of the company by really developing this drone platform. And so I mentioned the components. So why us? We've been working over the last 4 years, really focusing on developing those in-house different technologies that eventually allow us to put together a drone in a Lego style and in fact use it as a platform to launch different types of drones rather quickly for different applications. And I'd like to spend the next 4 minutes, 3-4 minutes, really talking about the two products or the product lines that we've already launched in the market. They're commercialized and they've been used for the last couple of years in different applications. And that is the fast optical wireless telemetry and our thruster technology. As you can see on the left-hand side, it says commercialized Swiss made. So let me start with the wireless telemetry. Basically, we are addressing the high-speed Wi-Fi underwater need. As the industry, specifically offshore industry, is focusing on unmanning their operations in the sea, they are increasingly looking to autonomous vehicles to do the jobs of inspection, maintenance, repair, interventions jobs. In order to do that, you need to create an infrastructure for those vehicles to actually connect to the operator on the beach and be able to do those, follow, let's say, commands, and then for an operator to be able to see what's going on. And so while acoustic provide a nice way to communicate between the vehicles and infrastructure, it's not strong enough or it's not fast enough to provide a high bandwidth data exchange between a vehicle, say, an infrastructure asset. And so what we're saying is basically our technology enables you to stream Netflix underwater. And in reality, it is this. So if you think about it, it's like having Wi-Fi in your office and in your home. You can stream Netflix, you can have video calls. The moment you get out of home, out of the office, you lose that link because the Wi-Fi that you have in the office is really a short-range Wi-Fi, high speed. That's exactly what optics provide to you. Underwater is giving you this short range up to 100 meters, 120 meters by high bandwidth data exchange. So we are focusing on miniaturization and affordability. So anything that we develop must be really small to get on a small vehicle, or could be easily retrofitted into an existing sensor or infrastructure. And at the same time, it should have a cost that would not eat up your budget if you want to put a number of those devices around. And so Luma, as you can see here, is a really small device, and it's quite affordable. There are different application ideas that we've been exchanging with key players in the market space. One of it, as I just mentioned, is network-based communication, kind of creating a Wi-Fi bubble around an infrastructure asset that allows a vehicle to communicate and really see the asset, communicate to the operator on the beach. We've trialed and we've showed already that our Lumas work in relatively well. They send a video in ambient light. On the left-hand side, it's a video from a pool demo that we did in Norway. I don't know if the bandwidth here for this presentation can allow this, but I'm just now running this video. Maybe it will be jumpy a little bit. On the right-hand side, one of the deployments that we are very proud about last year was in the South Pacific at the depth of 4,200 meters, roughly 13,000 feet. Deployed a number of different offshore applications. So So optics versus acoustics. Optics is relatively new technology that some people have heard, some people have not, and many people ask us, so, okay, why would we use that? And so I guess the key benefits go down to the fact that the optics are significantly faster than acoustics. So for instance, send this 50 kilobyte image, it will take you 1 second with our Luma 500 ER unit, and it will take 50 times so much with the fastest acoustic modem on the market. It is also significantly less power hungry. Our device will eat significantly less energy, 500 times less than your best acoustic modem out there in the market. And optic communication doesn't mind traffic, which is good for defense applications because it doesn't create any noise, and it also good for very busy construction work, for instance, where there's a lot of ROVs creating noise. And optics just send a signal silently. And this technology has been proven through different deployments with Ocean Installer, ITEX 7, River Offshore on Equinor sites in North Sea and Total sites as well. All right, so, and one more minute just on our thruster technology. That's another piece of technology that we already have available for sale, and that is ultra-thin hubless thrusters. They're quite unique because they are tangle resistant, they are hubless, so you don't have a problem entangling your equipment in a fishnet, a stranded fishnet, or a water plant. It's hydro-lubricated, there is no oil involved, so it can really go to any depth. It's pressure-proof, it's simple design, really simple design. I can show how it looks like with my hands in the breakout room if interested, and it's a patented technology. And so to finish off, I guess, with this, we already have some traction. A number of ROV manufacturers have bought this equipment and are so far pretty happy with it. And we've just were able to kind of address all the demand. And thanks to COVID, we were able to build finally some stock that we are able to ship those thrusters within 2 days. So to sum up, Hydromea is a credible revenue generating SME with protected IP. We have an experienced team with a number of advisors, and we really focus on execution. Plus, we have this really rare combination of underwater technology expertise under one roof with 2 engineers who have significant skills, quite nice complementary skills together. And so we are focusing on really opportunity to augment strategic value of the business through development of this autonomous underwater inspection platform that will result in this drone. So if you're interested in investing, we are raising our round in the next couple of weeks. We're starting kicking it off. And we're also looking for partners on development or market access. Thank you very much for your time, and I'm ready to answer any questions.
So Igor, thank you for that great presentation. You have about 8 minutes for people that would like to put questions into chat. Again, when you go to the breakout room, you'll be able to have direct communication, but right now we're trying to get the questions to Igor via chat. So the chat is the little bubble in the upper right-hand corner, and you can send the questions either directly to him as the presenter or to everyone, depending on your interest. Maybe I can just ask Igor while we're waiting, hopefully for the first questions. I think I heard you say that the communication bandwidth, particularly at the capabilities you were talking about, was about 100 meters, is that right? And yet you were testing something at 4,200 meters. Can you explain how far this will go, and is there degradation if you go further, that kind of thing?
Yeah, so it's very important not to confuse, and I'm sorry, maybe I was not very clear, the depth at which the devices work. So these devices work down to 6,000 meters or 18,000 feet. At least this is what it's been tested to. That's the test tank that we had access to in Germany. That was the limit. So we believe that it can actually go even deeper. But it's another thing of the distance of how many meters it can actually communicate one to another. And this is what the optics provide you is not unlike acoustics, it's for short range communication or near field communication. And as I said, our current unit is able to exchange data at about 50 meters. And the one that we have right now in development, we are going to be stretching it to about 100, 120 meters. And also so you'll be able to stream HD quality video over 100, 120 meters in good conditions. So of course it depends also on the clarity of the water. The deeper you go, the easier it is. But in the shallow waters where the waters are murky, you start to lose a little bit on the range.
Great. Hopefully you're getting some questions via chat.
Yeah, so one question from Melissa is if our company sees or open to adjacent development. Yes, indeed, we certainly are open to discussions around that, as long as it falls within the strategy that we have and complements what we're developing, what we're focusing ourselves on. Question from Chris Ward: is there any relationship between turbidity and the range? Yes, there is. It's basically the murkier the water is, the lower the range will be. Now, we have already some deployments in the North Sea on construction side in relatively shallow waters, and that was a concern with ROV teams that were deploying the Luma, that they might not communicate well. So in that particular project, it went all extremely well, and they were pretty impressed with the fact that even they did not see it visually, they still received data. And the reason it was possible is because we have a lot of error correction built in our system, and so we're sending much more packages than needed. So there's a lot of kind of loss. We kind of plan for a lot of loss, and so we're really capturing light at the photon level. So we normally can get the data, but there's no question. If you have a crystal clear water, it's going to go without any problem. For longer distances, the more turbidity is in the water, the distance reduces. There's another question from Phil: how effective is the Hydromea in the low temperatures like Arctic environments? We do not see a problem in Arctic environments with neither of our technologies, but to be fair, they have not been tested, although I take it back. We had an under ice deployment with our drone, and this drone was using thrusters, and it worked very well. So normally it should not really affect, but we don't have data to back it up today. How much power uses Wi-Fi? So the units in the sleep mode, they're using really very little, like 5 milliwatts or so. At the full blast, it can go up to 4 watts. And the trick is that it can really quickly exchange information. So depending, of course, on how much information you have, acoustic modem has to stay on for a longer period of time to transmit all the data. For optics, it's really quick. As I give you an example, 50 kilobits image can be sent in 1 second, and then it goes to sleep again, versus for acoustic, it takes 50 seconds to do that, if that makes sense. Is there an onboard turbidity sensor to monitor this? No, there isn't. What we're building I can't really talk much about it, unfortunately. Some of it is confidential, but we're addressing this issue. We found a way to better manage this. Have you installed Luma on your autonomous vehicles, and what applications? So our autonomous vehicles have not been really used a lot at this point of time. The autonomous vehicle that we've ran, which is called Vertex, we were not using Luma there. It was actually almost like pre-Luma times. We did have some capability in optical wireless technology, but not enough to put it on our drone. So all the deployments that we have with Luma come from our clients using it, and those that can share with us the experience, and if they allow us to talk about it, we do. On our website, you can check the news section. There are some news bits from some of the customer deployments that allowed us to speak about it. What is the wavelength? So you mean like, okay, so that's a good question. I don't have an exact answer to this right now. We can take this question in the breakout room where my technical colleague will be by my side. I'm a business guy. Sorry for that. Can the optics units work in series to extend range? Yes, they can. So the beauty of the technology that we have developed is that the units by themselves, they're point-to-point units. So we can kind of avoid this expert license issue by the fact that they point to point, so they can only communicate. They will only communicate one to another. But there's a lot of flexibility in the software, and we can open it up, and we can basically do we can arrange it in a mesh network, and we can do relays with them. So one of the examples that possible applications that we're discussing with the company in the risers business, they're wanting to connect their sensors on a riser so that you have real-time feedback from the sensors all the time, continuous monitoring.
Igor, we're going to have to stop you at that point, but it's wonderful that there are all these questions, and that means that there'll be a number of people coming to your breakout room. Thank you very much for the presentation and the very short, informative answers of your Q&A. Sorry, Igor, go ahead.
Oh, no, just thank you very much for giving this opportunity. I appreciate it.
Yeah, good, and good luck with your fundraising. So the next speaker will be Sam McDonald, the CEO of Deep Trekker, and we look forward to hearing from her.
Good morning, everyone. Just a quick check of technology. Do you have my voice as well as my slides on the screen?
We do.
Fantastic. So first off, a big thank you to TMA for hosting this, and certainly for having us. We've been members of the Maritime Alliance for some time now and find significant value and support from the entire team over there. So we are going to talk today about Deep Trekker, which is all of my hopes, my dreams, and my baby. My name is Sam McDonald, and we've been running this company for 10 years now. I can't believe it's been that long, but it's certainly true that I don't run it on my own. Okay, I'm gonna have to. There we go. Sorry about that. So I don't run this company on my own, and this is our leadership team over here at Deep Trekker. And I'd like to show this slide. If you are looking at a company to invest as a customer, as a partner, or certainly as a financial investor, it's important to know who you're dealing with. I don't know what's happening. Hey guys, just a quick stop. There's something that has happened to the presentation. Can you still see the slides? Are you looking at a wonderful picture of 3 tall guys and me?
No, we're back to the first slide.
Okay. All right.
Oh, we now see a guy with a hat.
Well, he's a good looking guy. Yeah. There we go. Back to these guys. I think I have things under control here. So, so yes, of course, that's me, the smallest one there on the right hand side. I'm Sam McDonald, the president of the company. Also on our leadership team, Jeff Lotz, Sean Phillips, and Sean Petty, all mechanical engineers, and individually, thankfully, not all the same age, top of their class here in Kitchener-Waterloo for mechanical engineering. So I surrounded myself some great talent. I happen to know all of these 3 folks from a company I used to work for in the forestry equipment industry, and that will come up later when we're talking about our guiding principles here at Deep Trekker. And so who are we? At Deep Trekker, we are agile, and we are passionate, and we are innovative, and that is important for a company that you're going to be dealing with, and it's certainly important for a company that's going to be lasting. And I certainly wouldn't want to buy from a company, invest in a company, or partner with a company who wasn't going to be here for the long run. And we do have that milestone of 10 years behind us now here at Deep Trekker. So getting to know us real quick, we are headquartered in Kitchener, Ontario, Canada, which is known as the Silicon Valley of the North, or Tech North, Tech Triangle here. Our family, we have actually over 60 employees now and 17 dedicated engineers. Proven engineering and manufacturing, coming up on that 10 years. We wouldn't be here if it was just my voice and enthusiasm behind it. We back that up with products that are second to none. We are in 90+ countries, thousands of installations around the world, and in 10 different industries. A quick timeline of where we've come. We did incorporate the company in 2010 and built 300 robots out of my garage and my partner's basement. And in 2013, moved into our first actual facility, 3,000 square feet, right here in the same region. It also represented the first US military sail that we ever made, and not just the US military, but the US Navy SEALs, which was awesome. They still haven't told me what they're doing with our units. In 2015, it was our first line expansion. We introduced our pipe crawler. We'll be talking about our products here. And in 2016, moved into the facility we have now, 15,000 square foot right here in Kitchener, Ontario. And yes, we do all of our manufacturing in Canada. 2017, the Canadian Navy followed on with our first $1 million sales. Any company will tell you that, I think it says screen sharing paused, another window is on top. Okay, sorry, it looks like I'm back. Sorry about that, guys. Again, we're having some tech stuff. In 2018, we brought our crawlers to Europe and realized that the pipes in Europe are a lot smaller than they are here, so introduced our 320 mini crawler. And in 2019, our bridge technology, which I'm going to talk about, which runs the brains of all of our products, was introduced. And then the second generation of both of our ROVs, the DTG3 and Revolution. So who are we? Our principles guide us, design and engineering principles from the start. Being the only non-engineer, I could take this as something that says, you know, that maybe I'm not as important as I think I am, but I get to tell a fantastic story about our design and engineering principles. That layers into our technology, our bridge embedded system technology, coupled with the mechanical systems that come from that legacy of forestry equipment. These things are made to last. People take them out of the box and tell me all the time how rugged and capable they are. This layers into our complete line of many products, and of course that layers into wonderful logos and customers and literally hundreds of thousands of applications around the world for these types of products. So what do? We make rugged submersible robots that make complex inspections simple. And what do I mean by that? So we have, of course, we're with the Maritime Alliance, so I'm going to focus on the DTG3 ROV and the Revolution ROV, so remotely operated vehicles. We didn't invent these. Certainly when I came up with the idea standing on the back of my boat, I thought, hey, I've come up with something completely unique. However, ROVs have been around since the 60s. We have just taken the feedback from the market and really built specific ROVs that are made for these applications that our customers tell us about every day. So I'm going to run a quick video here to give you an idea about what we have here. So the DTG3, Deep Trekker Generation 3, remotely operated vehicle. It's about the size of a basketball. It is made of cast aluminum side bodies with the thrusters tucked right in there for full ruggedness. It is completely portable. One case, take it out of the box, deploys in 10 seconds or less. Into the water, we can do, of course, water containing and submerged infrastructure inspections very, very quickly. We can do hull inspections. We've got our weatherproof controller here, so we can, you know, we don't have to rely on any other technology such as a tablet or a phone. We can simply put the video right onto that handheld controller. Can we work under the ice? Can we work in harsh conditions? Can we work in confined spaces? We say yes to that. Full 4K video coming up, over 400 meters of tether, and that is copper tether. That's important because it's cheap, it's easy, you can step on it, and it is very, very rugged. We've been involved in applications taking devices out of the water and garbage that's not supposed to be there. We can integrate great tools like sonar, USBL right onto our handheld controller. We have software that combines IMUs, USBL systems, and sonar to create a seamless experience on the DTG3. So moving right along, we're going to talk about, I've talked about most of these specifications. I've included this so that after the fact you have that for you with our specs on the DTG3. Moving right along, we're going to move into the DT Revolution, and it is revolutionary for sure. Not, I'm sorry, is someone speaking? No? Okay. The Revolution is not just revolutionary because it is, you know, rugged and built to last. It's got carbon fiber, but it also has this revolving head. And it's very important because you can position your 2-function grabber and make it into a 3-function grabber. You can position the camera in anywhere between 270 degrees, and you can also position the sonar head. And this is really important when you're doing inspections in low visibility. So you can position that sonar head in any position so that you can get the optimum viewing capability. So the differences between the DTG3 and the Revolution: 3.5 knots of speed, up to 1,000 feet. Of course, we have that 4K camera, and you saw that 7-inch screen there, and we can go into the details of that in the breakout session. Now, both of these, plus our other 4 robots that we have in our lineup, run on what we call the bridge technology. And essentially, bridge is a PC talking to another PC. So that's the PC in the unit talking to the PC in the handheld unit, and the communication protocol in between. And what that allows us to do is really build any robot on one platform. So it's an intelligent technology platform that we developed from the ground up. It allows you to have enhanced viewing capabilities over greater tether distances. That's that 4K over 800 meters. This has never been done before. Auto stabilization, swappable memory. Integration is paramount, and that's really the reason we developed the bridge. Hardware and software connectivity with third-party stuff. We don't make sonar. We don't make USBL and positioning, but we want to be able to seamlessly add this onto our robots. So we can move direct sonar integration and that proven third party with a lot of different partners. Control, precise camera and reliable stabilization. So we've got really robust algorithms and mathematics behind this that allow, really any camera to be put onto the DTG3 and Revolution. Ethernet wireless capability. So we can have that wireless capability. We still have the wire from the bottom to the surface because we want to have that real rich video in real time. But if you want to have that remote control over long distances, we have a Wi-Fi capability, so you can watch and control the units from virtually anywhere in the world. So the industries we serve, and these aren't folks that we're guessing about, this is where we've sold. We sell into up to 10 different industries, everything from aquaculture, municipalities, maritime defense, commercial diving, and thousands of applications within those industries. We have long-standing customer relationships. People come back to us time and time again. I love putting up some of these great logos: Exelon, US Navy, Los Angeles Department of Water and Power. We've been at this a long time, and people come back and upgrade on a yearly basis. UN Sustainable Development Goals. This is important to me. When I put the ROVs in the water, I see the problems below the ocean. We also are making things affordable and accessible for doing things like aquaculture in underserved countries. So we are in a number of different of the UN Sustainable Development Goals, and we're proud of that. Our ask: we would like to source worldwide customers, reseller, and technology partnerships. I do encourage you to ask questions in the chat and join me in the breakout room after the sessions are complete. Thank you so much for listening to me today, and thank you again to the TMA.
Sam, thank you. Great presentation. You're just under 12 minutes, so you've got about 8 minutes for chat via, Q&A via the chat. So very interesting technology, all the things that you've done. The bridge sounds very interesting. Do you sell that to anybody separately, or is that only for your own products?
That is our secret sauce, Michael. So that is something that we have here. We have mechanical capabilities, which I consider to be second to none, bias included, but we are able to put out mechanical technologies very, very quickly, and now with the bridge, turn those into marketable products in record time.
Hopefully you're getting Q&A that's being directly sent to you.
I don't have anything. I think I did a wonderful job and nobody has any questions. So it's either a good thing or a bad thing when the audience is quiet.
Well, you did a great job. So let me ask you a question. You said you built 300 of these in I think your basement and somebody else's garage or vice versa. How many of you have you produced and sold in the interim?
We don't give out the exact numbers because the competition is hot these days and they'd love to have that, but I can tell you that it is in the multiple thousands. and we do have those installations in 90+ countries. Since I do have a little bit of time, I would like to talk a little bit about what the bridge technology is, and maybe this will inspire a few questions. So one of the things, the coolest things about the bridge is those integrations of those third-party technologies. So as I mentioned, IMUs plus USBL plus sonar plus Doppler velocity log, and these are technologies that most folks in the ocean space are aware of. We've taken with the bridge technology and be able to stitch those together and really bring out the autonomy of units. So traditionally ROVs have been, you know, you've got a user who's driving them, and any input that is given to the ROV just does that and continues to do that until, you know, gravity or friction stops it. But with the integration of these new technologies and really the miniaturization of this technologies coming on, we can take our, you know, one-man portable units and really make them into either supervisory control, which means you're getting that real-time data, but you're not doing a lot of input. So that's waypoint navigation, stabilization. But it also offers us the opportunity in the future to take the tether off and have a hybrid unit, both with the DTG3 and the Revolution, in theory being an AUV and an ROV at the same time, which is really cool. So I'm seeing a few questions. Are you open to adjacent development, and what types of partnerships are you seeking? Are you questing distributors? Yes, yes, and yes. So we are absolutely open to other folks. As I mentioned before, we are a chassis for some third-party integrations, but we have developed in tandem some specialized tools with other companies. And partnerships that we're seeking are that very thing, as well as resellers around the world. We have a reseller network of 46 now, and we're looking to expand that in a great way. And now, which IMU are you using? We have one for a wave. We are looking for one for a wave energy converter. So I will send you, Jay Marcus, that information to you right away. Michael's asking me, can you tell us 1 to 2 particularly unusual applications that you've been asked to help with? You know, the stories we tell aren't necessarily the money that's made, but they're still pretty cool. We had a fellow who was doing some filming of hippos for Nat Geo, and if you know anything about hippos, I didn't before, they're one of the most dangerous animals out there. So he wanted to use one of our crawling robots to film the hippos, but he had a very specific camera that he wanted to use. So we built an integration for his camera, and we're involved in filming these hippos. But some of the, you know, the more mundane work that we do is in the energy sector, and we've been able to integrate a number of different sensors for that particular industry overall. Other cool things we've been able to do that make for great PR, we were involved with the 75th anniversary of the USS Arizona sinking in Pearl Harbor, and we got to be inside of that ship. So of course, a very important vessel for American history, and we got to survey a lot of the inside and actually place some environmental sensors. You know, time takes its toll on these vessels, and it is it's no different for this one, historical or not. And so they're deciding what to do with the Arizona as nature takes over and she's about to collapse. So we got to be a part of that important work as well. And then up here in Canada, the British expedition, the Franklin expedition to find the Northwest Passage, lost 2 ships. If you ever want to watch a great documentary, please look that one up, the Franklin expedition. But we were involved in finding the 2 fated ships that are in the Canadian Arctic as well. So some really cool stuff. I have a question from Tamara. As an educator, what skills are you looking in the next generation of up and coming employees? The #1 thing is passion for what you do. Find something that serves your love and go after it, even if it's not with us. With us, we're looking for folks in engineering. We're looking for folks who have a background in marketing. We're looking for folks who have a background in software, as well as remote communication. So those are the big ticket items here at Deep Trekker. And then, of course, a really strong group of folks to fill in the sales and marketing and administrative side of things as well. Have you had applications for searching for dangerous waste on the sea floor? We absolutely do. We've been involved in looking for radioactive waste, and we are also involved with defense applications in EOD. So those would be mines that have been placed historically as well as mines that are being placed today. So we have been involved with that. Sonar and USBL and positioning becomes of utmost importance, as well as the ability to add payloads for neutralizing those types of things or removing dangerous waste from the seafloor. And we've been involved in all types of applications like that. I believe I've covered off all the questions, and I don't want to go over my time. I will be in the breakout room and can answer some of those nitty-gritty, deep and dirty tech questions. So I look forward to seeing you there.
Sam, thank you. That was a great presentation, and you came in about 18.5 minutes. So hopefully you will have a number of people there. It sounds like 1 or 2 people were trying to find out if you could work with them. So that's really excellent. So let's transition to our third speaker, which will be Sean Newsom from Subsea Sail, which is a local San Diego company.
Well, good morning. Thank you. First to check, does everybody see my presentation?
Yes, yes.
Okay, great. My name is Sean Newsom. I'm here to discuss Subsea Sail, a manufacturer of unmanned systems in San Diego, California. I really appreciate the time. TMA BlueTech, thank you. Excellent presentations by Igor and Sam. And I appreciate all of the people attending. So, see, I'm just trying to, all right. So we're going to talk about the problem that we address at Subsea Sail, an ocean sensing platform and payload platform. Of course, the ocean is enormous and there's massive amounts of data to be collected. The interface between the ocean, but all the way to subsea to satellites at the surface is a very difficult region, obviously, with bad weather, bad actors. And current systems are very complex and can be very expensive to deploy, especially if you need to do survey in very broad areas with multiple systems. These swarming missions can be very costly. And rigid platform designs make it very difficult to customize a system for the application. Many USVs or unmanned surface vessels also are limited in power and duration, and they can be vulnerable to bad actors and bad weather. Subsea Sail offers many solutions to these issues, and we'll get into them in more detail shortly. So about the robotics market, the robotics market is expected to grow by 7.5 billion by 2025. This has been supported by research from Technavio and Grandview Research. And I think I would like to call your attention also to the U.S. Marine Corps 38 Commandant's comments on stand-in capabilities and the need for unmanned systems and silent platforms in our oceans waters, not only to take the human factor out of the equation in some of these dangerous missions, but also to simplify and spread the ability to get data and payloads in larger areas. Our primary users are government, academia, defense, and industry. Primarily, we've been working mostly right now with government and academia. So who are we? We're an innovative developer of unmanned semi-submersible sailing vessels, or USSVs as we call them, unique and capable platform sensor developers as well. Our systems are engineered for simplicity, and I'll explain that in a little bit more detail with our Gen 6. You see the silhouette up there in front of us. We're disruptively economical. This is very key. So we can permit swarming and fleet applications at a fraction of the cost using traditional systems. We're very highly scalable and variable. I like to tell people that we have 3 key platform patents, and from those we can develop a multitude of systems in terms of the size and scale and complexity. We're also highly sustainable, long duration, wind propelled, and solar powered. So what we do, we have the Generation 6 or Gen 6 system, which is at TRL 9, based on the fact that we have the Army Corps of Engineers using the system successfully for underwater or unexploded ordnance detection and turbidity assessments. We also have the Gen 6 Mini USSV, which is about 60% less in weight, about 14 kg. We have a reconfigurable rigid acoustic array on that sensor side, We have a provisional patent for that. And this is a very low-cost sensor. When we put a swarm, say 3 or more of our vessels in a broad area, we are confident we can detect things that haven't been detected before, either unmanned underwater vehicle intrusion, anti-submarine warfare applications, marine mammals, etc. One of our partners and lead engineer also has a magnetometer patented that we'll be adding to our sensing capabilities. We also integrate third-party sensors and payloads. We've done that with Xylem. We've done that with AUVs. We've done that with RBR on the CTD side as well, and on and on. And we provide multiple vessel coordinated or swarming teaming concepts of operations with our disruptively economical and simple platform. And we, of course, always collaborate with sensor and payload manufacturers, reducing the cost and complexity of unmanned systems. And of course, I want to talk about the sustainable development goals. We feel we fit into at least 6 of them. So let's talk about how we arrived where we are. We started with a concept. Mark Ott and Chris Totter, our engineers, came to our managing partner, Michael, with a concept for a platform that was persistent. And you see the drawing in the upper left. That drawing became the model that you see in the center, which represents our Gen 6 platform. And then, of course, in reality, we're now sailing and delivering systems. We have a very strong IP portfolio and roadmap. I want to call attention to these 3 key patents. One is a platform with a hull below the waterline. What this does is it reduces drag significantly, provides little to no wake, and with an option to sink from bad actors and bad weathers, and I mean completely, our sail floods and we can go to 10 meters at a minimum. It's a very capable system in terms of hiding from bad weather and bad actors. We also have, and this is a key to me, a patented wing sail control mechanism, passive system. We are able to set the sail at the optimum angle, given the wind speed and direction, with respect to the direction we want to travel autonomously or manually. And it's done without any lines, pulleys, or electronics. I mean, this is truly revolutionary. With just a few dollars in parts, we're able to control the entire wing sail. This has commercial applications. It has consumer applications. With small catamarans, for example. So you can literally sail a sailing vessel by just controlling the rudder with our patented passive wing sail control mechanism. We also have a patent for photovoltaics within that wing sail, obviously improved aerodynamics and a simpler design. And then I mentioned our passive acoustic array. A provisional patent has been applied on that with our partner Applied Ocean Sciences. So just a quick look at the platform itself. You can see payload areas at the top of the wing sail, bottom of the wing sail, where there's a deck area for solar. Solar can go on the wing sail. The circle calls attention to the only electromechanical part required for our system to sail, which is a servo to turn the rudder with a hotel load or operating load of less than 1 watt. At the section below, our bottom hull, we carry the batteries and ballast, a thruster to get out of harbors or to loiter in low wind conditions, and also to carry payloads, both integrated within the hull or suspended above or below the hull. Here's a video of the system working in Sea State 4 off San Diego with 25 to 30 knot winds. This is a demonstration of the system sinking, film made by the Advanced Navy Technology Exercise Command in Gulfport, Mississippi. They have interest in the system as a mobile gateway buoy to communicate between their unmanned underwater vehicles, motherships, and satellites. Just an example of how this technology can be scaled in different ways, carrying AUVs, delivering large cargo. We were asked to look at delivering 5,000 gallons of fuel. I want to call attention to the drawings below of the catamaran. We do have a working version of this, our Generation 2. It can surface all the way to the surface, and what that does is allow us to get right up on a beach or carry a heavy payload or launch and recharge unmanned aerial systems operating as a lily pad offshore. So multi-mission capabilities in alphabetical order, cargo delivery and pre-position of goods. This is something we're working on right now. One of our defense clients is asked to deliver a 55 kg payload. Communication gateways, as I mentioned, singly or in swarms. we can communicate subsurface from the bottom to satellites and cover over the horizon because we can put multiple systems in the water at our disruptively economical price. Multiple defense applications. I already talked about the unexploded ordnance detect, mine countermeasures, acting as targets and decoys, and of course intrusion detection, which is something we're working on very closely now with some of our partners. Of course, a sensor platform, that's what an unmanned system is, in single unit or swarm, so we can protect marine protected areas, exclusive economic zones, and provide weather and situational data above and below the surface. And I mentioned underwater, unmanned underwater vehicle delivery. We can act as a docking station or say carry a limited power system a great distance and release it to perform its mission. And then of course I mentioned UUV launch and landing platforms. We have a very strong management team. I can talk about them in more detail in the breakout session. I want to call your attention particularly though to Chris Totter, our lead engineer. He's been on 7 America's Cup campaigns, every one of them for the last 40 years except the last, and one as a technical director with the Oracle Trimaran in 2010. And I just think that speaks to the capabilities and skill we have in developing wing sail controlled unmanned systems. So who are we looking for? Of course, we're looking for clients. Army Corps of Engineers is our first client, and they wrote a very nice press release on their success with the system, both in detecting unexploded ordnance and turbidity. We're speaking with potential academic, industrial, and military customers. We're obviously looking for channel partners. We just recently signed Blue Zone Group in Australia and New Zealand. Very good defense contractor in the region. And we have discussions in multiple countries right now. We're of course looking for advanced investors. We're financed internally to date, looking to raise about 2 to 3 million to accelerate our R&D, marketing, and product development. It could be from a financial or strategic partner. And we also are interested in international sources to support our office development in Europe. And of course, management, improve our management. And then all of our sensor and technology providers and users. So we're looking for a number of technologies and a number of testers and additional clients and customers. That's about it for now. I look forward to taking your questions, and I appreciate your time.
Thank you, Sean. So please put your questions into chat for Sean. I see that you've got a couple already there.
Okay. I'm trying to pop the chat window back up. I've lost it.
Sean, the first question is from Rick Miller. How do you manage collision avoidance?
You know, that's a really good question. We certainly have the capability to add collision avoidance sensors and software to the system. I want to point out that our system is about 28 kg. It's considered flotsam by the U.S. Coast Guard. So we're not too concerned about collision. And I think if you were to actually look at the possibility of a large ship striking any small vessel, generally they'd be washed aside. We're looking at having that analyzed as well. But we can add collision avoidance if the customer requires it. There's a number of ways to do that. At the size and scale we are at about 3 meters and 28 kg, it's not that much of a factor right now. Of course, when we get into larger systems and scale up, that can become an issue, and maybe a more formal collision avoidance system is required.
Great, thanks. The next question is from Rafael Ramos. What are the maximum payload, maximum transit speed, and endurance?
Great question. So maximum payload with the G6 is about 20 kg, neutrally buoyant. We can go higher or bigger in volume based on the hydrodynamic design. Our speed is currently a maximum about 2.5 to 3 knots. Of course, that can be scaled up by scaling our wing sail. So if you want a racing version, we can provide that. The last question was, I'm sorry, give me the last part of that question.
What is the maximum endurance?
Endurance is theoretically indefinite. We're going to be limited by biofouling and some sort of issue mechanically or electrically with the system. So we're not really sure what our duration is. We've done a long-term test off of 8 days off of the West Coast, We're currently preparing for longer and longer missions, one as early as next week with 2 systems starting up in the Bay Area. But it's really the limitation of the mechanics and biofouling. The system is replenishing its power through solar panels to a 500 watt-hour battery bank in the Generation 6 version, and it's only using less than 1 watt to operate when we're doing an autonomous sailing mode.
Great, thank you. The next question is asking if you can discuss the vessel signature.
That's a good question. We at Antex, we were looking at the vessel a number of ways, or the Navy was. They looked at it at IR. Depending on the sun and wave conditions, it would present maybe the spars and the 3/4 inch ID mast on the system or any sensors in radar. Visually, it disappears after a couple 100 meters. We can make it very proud, as we like to say in the Navy, with very bright sails and logos. But when we do a pure transparent sail, it's very hard to see over any kind of distance unless you're really trying to look for it. Audio signature, that's where our sweet spot is. We're very quiet because, again, imagine a tiny servo about 2.5, 3 inches long, and that's the only moving part on the system, especially without any pulleys, lines, and electronics for the wing sail. So ideal sensor for listening, for putting acoustic sensors in the water. As far as radar signature, I just don't see much of a radar signature. You have to imagine the small materials in the water with a wind shop behind it. It's just not something we're concerned about.
Okay, great. Thank you, Sean. We have 2 more questions to do very briefly. What is the business model, and do you sell or rent these?
Well, that's a great question. We're open to that business model. It's both selling of systems, development of systems that are suitable to the applications, and we can sell systems or software as a service or data as a service. So we're open to any type of model that is mutually beneficial both to Subsea Sail and the customer, of course.
Okay, great. And then the final question, what capabilities exist for video transmission and control from remote sites, or can this be added as a payload?
Very good. Right now, I just saw photos yesterday of our masthead camera that we're developing internally. Of course, you're limited in sending data, through Wi-Fi or Iridium, and so it's really the limitation of the comm system. We can get the sensor on there. And I'm sorry, the second part of that question, Melissa?
Sorry, can this be added as a payload?
Absolutely. We are a platform. I tell people unmanned systems are essentially dinner plates, and the customer tells us if they want breakfast, lunch, or dinner on it. So it can be a simple biscuit, or it can be a full meal. So really, depending on what your application is, we can apply sensors both above the mast, small ones, at the waterline and anywhere below the waterline, including suspending or towing small sensors.
Okay, and I do see that there is one final question, but I do think that Michael has a parting word, so we can perhaps make sure that's handled in the breakout session, or just handled through email. So Michael, if you would like to just kind of give any closing remarks, and I will just comment that the breakout sessions that'll start in about a minute or 2 are listed in the chat.
So by the way, I just want to let everybody know I'm having an issue with the chat, so I'm going to jump out and jump right back into the breakout session.
Well, the breakout session, yeah, is a separate number anyway, so everybody will leave this and start back in again. But Sean, so one question that came in was to talk regarding partnering for SBIRs, and that would be Sean Newsom. And the presentations and the recordings will be provided relatively quickly on our YouTube channel. So if you've not been to our YouTube channel, if you put into Google TMA BlueTech, YouTube, it'll take you there. We have about 130 videos, and there is a channel or a playlist for the BlueTech Global Connect. So you can look at the videos from prior webinars as well as the ones that were discussed today. And I see that Melissa's put Sean's contact details up. There was another question about logistics, so hopefully that will be something that can be asked to Sean in the breakout session. So I just want to say that 3 great presentations, 3 amazing companies, 2 of whom are looking for financing, all of whom are looking for partners around the world. So hopefully you will be able to join at least one of the companies in a breakout room and have a more in-depth discussion. So thank you all for joining us, and come back next month if you have an interest or any of your colleagues have an interest in offshore renewable energy. Again, we will have 3 companies from 3 different countries. I think right now Scotland and the United States for sure, and we're not sure of the 3rd yet. But every month, 3 great companies. So thank you. And then you can see here on the right-hand side in chat the breakout sessions and where you can go. And I think it's also in the email that you received from Sharon, our support. So thanks again, and we look forward to talking to you soon. Please give us any feedback you have. Thanks.